Alright, hello, welcome. In this video, we're going to be talking about polynomial arithmetic. So we're going to be adding polynomials, subtracting polynomials, multiplying polynomials, and also dividing polynomials. Okay, so we're going to start off with kind of the easier ones, with addition and subtraction, and then we'll move on to do multiplication and a little bit of division at the end. Now, the first thing you might see in your notes book is these two questions. Hey, can you add these and can you multiply these? And so, but I've noticed, and at least in my Algebra 2 classes this year, that we haven't really had a big issue with not combining like terms appropriately. We just did quadratics, and I didn't see anybody taking 3x squared plus 4x and calling that 7x to the third or anything like that. You know that it seems like you all know already coming in that you can't do anything with an addition like that. Now in the last lesson, we did see that we could multiply these all together. We could take all the numbers and group them together. And then we could take the x's and kind of group them together. And we could say, okay, 3 times 4 is 12, times 2 is 24, and x squared times x, that's going to be 3 total powers of x. Okay, we were able to do that. All right, so let's get to adding and subtracting. So I think one thing I do need to remind you about is the definition of like terms. Right, so terms are like and can be combined if they have the same variables and the same exponents on those variables. Now for us, that's usually going to be the same variable because this is pre-AP Algebra 2 with a mind towards AP Calculus, and that's a single variable calculus class. We only ever deal with one variable at a time in that one. So you won't see us dealing with a lot of like x's and y's combined together because it's not something you're going to do on this campus probably. But the commutative property, that's something that I think we've talked about, at least in my sections, a little bit, but I should probably remind you of. And that's that we can multiply two numbers in whatever order we like. So 4 times 3, that's the same as 3 times 4. And it works the same for addition, that like 5 plus 7 is the same as 7 plus 5. And if you think about it, this is true for any number of numbers that we're going to add together or multiply together. We can add and multiply in whatever order we like, and that's the commutative property. So let's get to it. Let's simplify, which really is just combining like terms, probably what they called it in your Algebra 1 class. So we're going to go over here, and we're going to say, okay, the like terms here are 15m to the 3 and 2m to the 3. So if I have, 15 of these things and I add 2 more of those exact same things, I'm going to have 17 of those things. So that'll be 17m to the 3. And m to the 2, I didn't have any like term to combine it with, so I'm just going to leave it like that. And then over here, this one, okay, I've got in terms of, okay, I've got x squareds here, and then maybe I'll use a different color. Numbers over there, constants. Okay, so I'm going to combine like terms. I've got 3x squared minus 7x squared, and then plus 5 plus 12. Okay. And so when I go in and I combine 3x squared minus 7x squared, that would be negative 4x squared. And then plus 5 and plus 12 is plus 17. All right, here's 2 for you to try on your own. Okay, so you should pause the video and work these on your own because the answers are just going to pop up here in a second. All right, there you go. So on the left, we just had x squareds, x's, and constants, and we just combined them with their like terms. But on the right, we had something a little more interesting happen. The b to the 5s, I had 4 plus 3 is 7, and then I lost 7 of them, and so I ended up with no b to the 5s. And all I was left with was these, first powers of b, the 8 plus 6 plus 1, and that's 15 of those b's. Now with subtracting, the message is that this is just adding after we've distributed a negative. So I'm going to do this twice for you. I'm going to show you the first 2, and then I'm going to have you and try it yourself on the second 2. So I'm going to start by distributing the negative. Okay. So I have this a to the 4 minus 2a, and then I'm distributing the negative over that 3a to the 4, that negative 3a. So negative 3a would be plus 3a, and then negative times 1 is negative 1. Okay. And then I'm going to kind of combine the like terms. You can rearrange if you like, because of what I was talking about earlier, that commutative property. Minus 3a to the 4 minus 2a plus 3a minus 1. And then it makes it easier to look at, oh, okay, a to the 4 minus 3a to the 4, that's going to be negative 2a to the 4. And then negative 2a plus 3a would be plus 1a and minus 1. So just take the first things, you copy them down, distribute the negative, and then we're adding after that. All right, so then on this one, I've got 3x squared minus 2x plus 8. Just going to kind of copy that in, minus 2x plus 8, and then I'm going to distribute the negative over to the x squared and the negative 4. So minus x squared and plus 4. Whoops. Okay. Then I don't think I really need to grab these and rearrange the terms to see what's going on. Maybe I'll use a highlighter this time. 3x squared minus x squared is 2x squared. And then, okay, with x's, there's nothing for me to combine with, so I'm just left with the negative 2x. And then the constants, that's plus 8, and plus 4 is going to be plus 12. All right, now maybe you should try these next two on your own. Okay, so you're going to work these, and you should pause the video now. All right, there they are. So, just after you distribute the negative, then it becomes just adding polynomials, which is combining like terms, which is something that it seems like y'all are pretty good at this point. All right, now I got a couple geometry examples for you. So, given a rectangle with length x plus 6 and width x plus 3, what's the perimeter of the rectangle? Okay, if you're not given a diagram, you should make one yourself. They told you that last year. So here I've got myself a rectangle. Okay, width is x plus 3. Okay, so that means this is also going to be x plus 3. Length, I guess that's the same as height, x plus 6 and x plus 6. Okay. Now if we want the perimeter of this thing, we're going to add all the side lengths together. Okay, so that's going to be x plus 3 plus x plus 6 plus x plus 3 plus x plus 6. Okay. So if I combine all the like terms, I'm going to have 4 copies of x, so that would be 4x plus 3 plus 3 plus 6 plus 6. So that's going to be 6 plus 12 is going to be 18. And that's how we find the perimeter in terms of x. So if we were given and we were given the whole perimeter and given the length of 2 of the sides, we could use subtraction to find the third side. So again, I'm going to draw a diagram. Maybe I'll draw one that's like not perfect triangle or anything. Okay, so they say the perimeter equals 3x squared plus 3x plus 5. And 2 of its sides, maybe I'll call these sides like A and B and C. 2 of the sides add up to x squared plus 3x plus 3. Maybe I'll just say, with no loss of generality, that a plus b are the ones that add to x squared plus 3x plus 3. Okay. Well, I know that perimeter is a plus b plus c. And so if I wanted to find c, I could take perimeter and I could subtract that a plus b. So I'm going to say c is equal to perimeter minus that a plus b, because that's subtracting a and subtracting b if I was to distribute the negative. Okay, so this is going to be 3x squared plus 3x plus 5 minus x squared plus 3x plus 3. So just like before, when we were subtracting polynomials, I'm going to say, all right, that's 3x squared, 3x plus 5, and then I'm going to distribute this negative over to everything. So minus an x squared minus a 3x and minus 3. Okay, so then I'll kind of combine like terms. 3x squared minus x squared is 2x squared. 3x minus 3x is 0, and 5 minus 3 is positive 2. All right, now we're going to multiply some polynomials. Okay, up at the top, you see these are all monomials multiplied together. Each of these, nothing added together. Okay, and we dealt with a lot of multiplication of monomials last time, so I'm going to just say, then we just learned about these last time, and we're just going to kind of move on a little bit. The difference today is that, okay, we're seeing some addition in here, so that's where we're going to need to use the distributive property. So let me just go in and, but again, this is one of those things I've seen y'all doing good with this. Okay, so I'm going and I'm distributing the 4x over all of these terms. 4x times 3x squared, 4 times 3 is 12, x times x squared is x to the third. 4x times 2x is 8x to the 2, and 4x times 1, well, this is going to be 4x. If you want to try these, try them and pause it. I'm about to put in the answer. But if you're feeling confident, you already know how to do this, good for you. All right, you're ready to move on. Let's multiply some bigger things by each other. All right, now in the last unit when we were doing quadratics, we had reason to multiply binomials by each other. Now generally it was just x plus a number times x plus some other number. So this is a little different because I've got an x squared and an x, and we really kept it to degree 2 or less up to this point. So I'm just going to remind you what we did here. We took x squared and plus 3 and we laid that one out horizontally. And then we would have taken the x, pardon me, it just keeps jumping around, x and the plus 2 and lay that one out vertically, and then we're just going to multiply each of the terms together and fill out this grid so that we don't forget to distribute any of the terms on each other. Now with binomial times binomial, this is fine. I don't think it's totally necessary, especially if you know you're going to do it right. But with larger products, like we're going to see here in a second, I really recommend using the box method. So x times x squared, that's x to the 3. X times positive 3 is positive 3x. Positive 2 times x squared is positive 2x squared, and positive 2 times positive 3 is positive 6. So I go through and I combine all the like terms. I see, there are no like terms. So this is going to be equal to x to the 3rd plus 2x squared, 3x, and positive 6. Let's try another one real quick. So I'm thinking for the sake of space, I'm working on kind of like a wide screen area. I'll put the trinomial sideways and then the binomial vertically. 2x squared, negative x, and positive 2. I'm going to multiply that by an x and a plus 3. All right, so 2x squared times x is going to be 2x to the 3rd. X times negative x is negative x to the 2. 2 times x, well, that'll be plus 2x. Okay, and then I'm going to go in here and multiply everything by 3. So 2x squared times 3 would be positive 6x squared. Positive 3 times negative x is negative 3x. And positive 3 times positive 2, that's positive 6. So now I go through and I combine my like terms. And in this situation, I do have some like terms. I have right there, plus 6x squared minus x squared. I can combine those because those are both x squared. Same variable, same exponent. And then minus 3x plus 2x, I'll be able to work with those as well. So I'm going to say that this is equal to 2x to the 3 plus 5x to the 2 minus x plus 6. Now, before we move on to the bigger ones, this in your notes book, it's asking you the question, what's the difference between these two things? And it's really a difference in parentheses, right, and how we're using the parentheses. If we're multiplying on the right 5x plus 3 over 2x plus 3, then we're going to need to multiply all of these things by each other. But without the parentheses, the only thing that's getting multiplied, the 3, like that. Okay, and so it's the difference in, am I going to be using the box, or am I just distributing the 3 over the 2x and the plus 3 is what I'm saying there. All right, now I'm thinking it might be about time for you to try a couple of these on your own. So I've got these two. I got binomial, and binomial, trinomial. And both of these I think would be right at your level right now. So why don't you try these on your own? You should work these with the video pause and then check your work against mine. And you should pause now because the answer is going to pop up in like 5 seconds. All right, there you go. So I set up the box, I distributed all of the terms against each other, and I combined like terms, and I've got myself a product. That's how you do it. Now these two, these are, kind of bumping it up a notch. These are trinomial multiplied by trinomial. So I'm going to show you how I would go in and do one of these, and then maybe I'll let you try your luck on the other one. So on the left, I've got x squared plus 3x plus 2, and it doesn't matter what order, which one we put horizontally and which one we put vertically, right? Because 5 times 3 is the same as 3 times 5. We've known that for a while. So x squared, positive 3x, and positive 2, multiplied by x squared, a negative 5x, and a positive 4. Okay. And if it helps you to draw in the actual grid to make sure that you're filling in all the terms, that's something that you can do. right? That's something that helps some people. So x squared times x squared, that's 4 powers of x. We're going to add those exponents together. X squared times 3x would be 3x to the 3. X squared times 2 is 2x. Okay. Multiplying an x squared by an x to the first, that's going to give me an x to the third term. Okay, negative 5x times positive 3x would be negative 15x squared. And then negative 5x times positive 2 is negative 10x. And over here, I've got 4x squared. 4 times 3x is 12x, and 4 times 2 is 8. Now I'm going to go through and I'm going to combine all the like terms. I'm going to have x to the 4. The x to the thirds, I've got 3 minus 5, so I got negative 2x to the 3. In x squareds, I got 4 plus 2, 6x squared along the main diagonal. And then 6 minus 15, that feels like negative 9x squared. Okay, in terms of x's, I've got 12 minus 10 is positive 2x, and then that last number hanging on there, that's plus 8. Okay, in the next one, maybe I'll show you how I would get this set up, but then, I'll let you try it on your own. So if I'm squaring this, remember, I can't just say that this is 4x to the 4, 9x to the 2, and positive 16. That's not going to work, right? That's going to be missing a lot of terms in the expansion. So I'm going to go over here and I'm going to say, all right, 2x squared, positive 3x, and negative 4. We're going to multiply that against 2x squared, positive 3x, and negative 4. All right. Okay, 2x squared times 2x. Oh, no. You're doing this on your own. Try it. Pause the video. Check your answer against mine in 10 seconds. All right, there you go. So just like the other one, I filled in the box and combined like terms. And that's really going to be the way that I would encourage you to always multiply out these products of polynomials like that. All right, now I'm going to do one of the geometry ones. I didn't even notice this when I was delivering the lesson, but this is the same rectangle that we were talking about earlier, I think. Width is x plus 3, and length is x plus 6. Okay, so we're not going to be finding the perimeter here because that's going to be addition, and we're working on our multiplication right now. Okay, remember that the area of a rectangle is equal to the base times the height. Okay. So this is going to equal, in our case, x plus 6 times x plus 3. And, maybe you don't need to use the box for this, and maybe you're going to say, okay, I just need to make sure I distribute the x over x plus 3, so that would be x squared plus 3x, and then the 6 over x plus 3, so that would be 6x and 18. And then that would be x squared plus 9x plus 18. Okay, maybe we've done this before. It's maybe not in the context of a geometry problem. All right, now let's talk about dividing polynomials. So I'm going to have to take it all the way back to long division of numbers, which is something that we've talked about a little bit at the beginning of the year in this class. But I'm going to remind you about how that works. Okay, what you do is, you take this number here, and you say, what do I need to multiply this by to get to the first one or the first couple of numbers? It's 18, really. Okay, what do I multiply 6 by to get 18? I'm going to multiply 6 by 3. Okay, so then you write a 3 up there above that last number. And then what we're really doing is we're taking the 3 and we're multiplying it by the 6, and we're going to copy in the result over there. Okay, oh no, lost the roof of my house and the other part of it too. Okay, and then we subtract the 18. Now, you might be like, why are you putting parentheses around the 18? There's no need for that. You'll see in a minute. When we go to do with these polynomials, I think it's useful to throw a parenthesis around there, especially considering the way that we subtract polynomials, which is earlier in the video. So 18 minus 18, we know that's 0. Okay, so then we drop down the next thing. Okay, and if 6 doesn't divide 4. 6 doesn't go into 4 any time, so I put in a 0 here. I multiply 0 times 6 like I did before, and I put the result there. And then I'm going to be, subtracting 0 from 4, and I'll just get 4, and then I will drop down the 5. And so I think to myself, what do I multiply 6 by to get to 45? Yeah, I know 6 times 8 is 48, but that's too much. So it's got to be 6 times 7, which is 42. It's a little bit less than 45. That's good. Okay, so 6 times 7 is 42. So I take 7, I multiply it in by 6. I copy that down over here. It just keeps jumping on me. It's going to drive me crazy. And then 45 minus 42 is 3. We drop down that last number. And we think, how many times does 6 go into 33? It's not going to divide it cleanly, but 6 does divide 30, so 6 times 5 is 30, and I'm just going to say, all right, there we go. And then I'm left with a 3 down here. Once I get to like the end of my number, that's going to be my remainder. And now I know that you know how to like go into the decimal realm and keep it going, but that's not going to be what I need you to do right here. It's not going to be helpful for us when we divide polynomials. We're going to say, all right, this is our remainder here. This number here, 3. And then what we did when we were cool with having mixed numbers, which in general I'm not, but was we took that remainder and we divided it by this number here on the outside. The divisor. I just went and looked it back up. I couldn't remember. It's been a while since I taught algebra. But that number on the outside that we're dividing by, that's the divisor, and that's going to be what we put the remainder over. So let's try this with a polynomial. Now, I know that there are easier ways to divide these two things, but I'm just kind of getting you started on polynomial long division because some of the more complicated examples, they can look a little intimidating. I don't want you to be intimidated by this because I want you to think that this is exactly the same as long division, and maybe you're good at long division, be like, okay, I'm good at long division, I'm going to be good at polynomial long division as well. So what we're going to do here is we're going to take this thing and we're going to say, hey, what do I multiply 2x by to get 20x squared? And I would take 2x and I would multiply that by 10x to get 20x squared. Okay, so I put that there. And then just like before, I multiply down. Okay, 10x times 2x is 20x squared. And then I subtract that and I'm left with 0. And I drop down this negative 4x and I say, what do I multiply 2x by to get negative 4x? And that would be negative 2. Again, I go and I multiply there. Negative 2 times 2x is going to be negative 4x. And this is why I recommend, putting the parentheses around it. So it reminds you that this is not going to, add to negative 8x. Okay, we're taking negative 4x and we're going to add 4x because we're subtracting negative 4x. And we're going to get a remainder of 0. Okay, so plus 0 over 2x. There's no point in writing it down if there's no remainder. So I'm going to say that this quotient is equal to 10x minus 2. All right, here's another one, and we'll just like ratchet it up a little bit by turning it into a binomial. Now, here in a few minutes, I'm going to show you another way to solve this type of one, but I'm going to save that for a minute, for later, because I think this is a good kind of introductory example. When we have two terms, we're only concerned with thinking about what am I going to multiply that first thing by to get whatever I'm looking for here. So what am I going to multiply x by to get x squared? That would just be 1x. And then I will distribute that x over the x plus 3. So I'll be getting x times x plus 3, and that'll be x squared plus 3x. So that's what I'm going to copy in down here. X squared plus 3x, and that's what I'm subtracting. Okay, so when I go in here, I'm going to be subtracting, let's move this over a little bit, yeah. X squared minus x squared, that's no x squared, so that's 0. And 7x minus 3x is 4x. Now I drop down the 14. Okay, now again, I'm thinking, what do I take x by and what do I multiply it by to get 4x? That's going to be 4. So x plus 4. I distribute the 4 onto the x plus 3. And I'll get 4x plus 12. And that's what I'm going to be subtracting. Okay, and so I'll say, okay, 4x minus 4x, that's nothing. 14 minus 12, that's 2. Okay, and once I get to, there's not going to be anything I multiply x by to get 2. Or you can see once I get down to the constant over here in my quotient, then I know that I'm at the remainder. Okay, and so that's my remainder is 2, so it'll be plus 2 divided by x plus 3. Okay, and that's how we're going to polynomial long divide. There is a faster way, though, for some of these, and so I'm going to show you that now, and it's called synthetic division. Now, the biggest thing I'm going to tell you about synthetic division is that in this class, Synthetic division is only to be used when dividing by x plus c or x minus c. It's got to be just like that very simple denominator, x plus a number, x minus a number. Okay? I'm not saying that it's impossible to use synthetic division in other situations. I'm saying in this class we're not going to use it because in my judgment, you're less likely to come up with the right answer than you would be if you just use long division. Okay, so what I'm going to do, I'm going to show you what we're doing here. We're going to take x squared, negative 7x, and 13, and we're going to copy out the coefficients only. Okay, so 1x squared, negative 7x, and positive 13. Right? And I'll show you where I'm getting those from right there, and right there. Okay. And then I'm going to kind of draw a little like house thing around these numbers. I don't know what else to call it. And then I'm going to, over here off to the side, I'm going to copy in whatever number would make the denominator equal to 0. Okay, so that's one of the places where you could go wrong. You just got to remember it's the opposite. Okay, so if it's x minus 1, I'm copying a positive 1 down there. And then the algorithm after that is exactly the same every time. We always start by dropping down the first number and just copying it right there. Okay, so that's 1. And then we're going to multiply and add, multiply and add, multiply and add, multiply and add until it's all over. Okay, until the grid is filled out. And what I mean by that is I'm going to multiply this one times that one. I'm going to copy in my product there. And then I'm going to add down. Negative 7 plus 1, that's negative 6. Then I'm going to multiply again. I'm going to multiply negative 6 times that 1 in red. Okay, negative 6 times 1 is negative 6. Then I'm going to add down. And then I'll be left with 13 minus 6, that's positive 7. Okay, this number we get here at the end, that's our remainder. Okay, and now I'm going to zoom. Oh, okay, it's got another example coming up here, but okay, that's my remainder. So when I'm going to write out the quotient, I prefer to start with the remainder, actually, work right to left. And so I'm going to say 7 is the remainder. That goes over x plus 1. Okay. Then the next thing after the remainder will be the constant term, then the first power of x, then the second power of x, and the third power of x, and so on, as I'm moving right to left. So I'm over here, negative 6 plus 7 over x plus 1, and then that'll be the number of x's. So this quotient will be equal to x minus 6 plus 7 over x plus 1. Let me do that again for you. So maybe I'll go a little faster this time. Okay, I've got 1x to the fourth, negative 2x to the third. Oh, I'm glad this one came up. Okay, this is something else that you need to be aware of. If there's a missing term, we can't just skip over it and copy 3 and 1. We need to put in the 0 as a placeholder for it. Okay, so there was no x squareds, 3x, and positive 1. Okay, just number. Okay, then over here, the number I'm going to kind of put off to the side, that's going to be positive 3. Whatever makes the denominator equal to 0. So put that out here, and then I'm going to start by dropping this down, and then I'm going to multiply, add, multiply, add, multiply, add until it's all done. Okay. And so I've got 1 times 3 is 3, and add down. Negative 2 plus 3, positive 1. Again, multiply again. 1 times 3 is 3, and add down. 0 plus 3, still 3. Multiply again. 3 times 3 is 9. I'm going to add down. 3 plus 9, that's 12. And then 12 times 3 is 36. And 1 is 37. Okay. So that last number I get down there in the bottom right, that's my remainder. And that's what I'm going to start with. Okay, so my remainder is 37. So it's 37 over x minus 3. Okay. And then these numbers over here, these give me the coefficients of my quotient. So I'm over here, I'm going to say that's plus 12. It's positive 12, and I guess plus the 37 over x minus 3. Then next, after 12 would be, we're going to increase the power of x by 1 each time. So that'll be 3x, 1x squared, and then 1x to the third. Okay, now I think you should try this on your own and see if you know what you're doing. So you're going to go in there, and you're going to divide x to the 3 plus 2x to the 2 minus 4x plus 1 by x plus 2. What I'm going to point out to you, though, is that be careful there. We're going to put negative 2 on the outside of the structure thing. Okay, so try it on your own with the video paused, and then check your work against mine, which is going to pop up in just a few seconds. All right, there you go. So I got x squared, no x's, -4, with a remainder of 9 over x plus 2. All right, now these last 4, I want you to try on your own again, but what I'm gonna show you is deciding which method to use. Remember, synthetic only works when we're dividing by x plus a number or x minus a number. So I'm gonna just mark the ones that we can do synthetic with. Okay, this one off to the right. Okay, we can do that because we're dividing by x plus 3. That's just x plus a number. Okay, x minus 5. Okay, we can do synthetic division on that one as well. Okay, but these other two, that 2x plus 1, that's not just x plus a number. Okay, that's 2x. Okay, that's not worth it. We're going to do long division. And then this one down here, divided by x squared minus x plus 1, that is not just x plus a number or x minus a number, so we're going to do long division on that one as well. Okay, now I would encourage you to try this on your own with video pause. I'm just going to pop up the answers because this video is already over half an hour, and I've got a whole video of me doing lots of examples of synthetic and long division and multiplication and division, in the examples video. So I'm just going to show you how this one goes and give you a chance to try this on your own. Here they come in just a couple seconds, so you should pause now. All right, there they are. That was a lot of division. Okay, so I went in and I highlighted my answers in yellow so you could see them a little more clearly. But I did long and synthetic. Okay, one thing I was going to point out was with the long division, that one in the bottom left, make sure that we're putting in our zeros for missing terms. And also that it didn't happen in that one because of the cancellation working out just perfectly. I'll kind of draw in blue an arrow right over there, how those things canceled off perfectly. That isn't always going to happen. Your remainder doesn't always have to just be a number, but in general, the degree of the must be less than the degree of the divisor. So it's possible that I could have had like x plus some number over x squared minus x plus 1, but it's not possible for me to have like x squared or x to the third as my remainder. Okay, that was a lot of arithmetic, a lot of polynomial arithmetic for one sitting. I really appreciate you watching all the way through with me. I hope this helped. Thanks for watching.